All right, and here we go with our last lesson of Unit 8, and we'll focus on the law of cosines. So we're going to be on page 113. Like I said, we're Unit 8, Lesson 9, law of cosines, and you can see that this applies to standards 20.2 and 20.4. I can find side lengths or angle values of a non-right triangle using the law of cosines and solve those application problems. All right, so I'm going to skip the opener. You can come back to that in a little bit. All right, you can scan that QR code, watch that video, and go through that. But what I'm going to do is jump into the notes on the law of cosines. All right, I'm not going to develop this for you. I'm just going to jump in and just give you the formula, all right, and let you work with that. So now, when we think about law of cosines, all right, so what we have, all right, is a squared equals b squared plus c squared minus 2bc cosine of angle A. All right, and so what we really have to work with here is notice this looks like the Pythagorean theorem, and there's some derivations that we derive this from where those things come from. The biggest thing that you need to understand is that the relationship here, right, whatever side we're solving for or whatever angle we're solving for, these have to be opposite of each other. So this is angle A, and this is the side opposite angle A. And then these are the other two sides, B and C, in the triangle. And so remember, this is for non-right triangles. And so when we think about this, that means that there's technically three valid equations, because we could have the a squared here, but notice we might have b squared equals, and then it would be a squared plus c squared minus 2ac, and then it would be cosine of big B. And we could have a c here, right? So c squared, and that would be a squared plus b squared minus 2ab cosine of big C, or angle C. All right, so and the biggest idea here is that when we do the law of cosines, all right, that the angle involved is, all right, always opposite the side you have. All right, so now, knowing which situations to use law of sines and law of cosines, all right, is important. So we talked about with law of sines, that's really angle, side angle, 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 side. So when we look at, all right, law of cosines, we're going to use this when we have side, 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 and or side angle, side information. So those are the two situations when we want to use, all right, law of cosines. And once again, so if we have all three sides, right, a squared, b squared, c squared, that means we can solve for the missing angle, all right? And then if we have side angle side, right, that means we are going to have this angle, and then we'd have the two sides around that angle, all right, which would be B and C, and then we could solve for the opposite side. All right, so let's just go through the steps here. So identify what you're solving for, typical first step, right? No matter what type of problem you're finding or solving, find its opposite pair, put those into in the first and last positions, law of cosines, fill in the rest, and then solve for your variable. All right, and so the other big thing here is to know, am I solving for a side or am I solving for an angle? And the big difference is, because remember, if you're solving for an angle, eventually you have to use the inverse trig function to do that. So just make sure you keep that in mind, versus if I'm solving for a side, all right, I just take the cosine of that angle, all right, as I go through my process. So notice I have an angle, and I want to know little a here. All right, so if I go back to, all right, my problem here, so a squared, or that's what I'm looking for, all right? So I'm going to have a squared equals, all right, I'm going to try to get this on screen here. So then it's b squared plus c squared. So those are the two sides here. And notice this is side, angle, side information. All right, there we go. And so then it's going to be 8 squared plus 11 squared minus 2 times 8 times 11. All right, and then cosine of that angle. Just like that. Now, here's the nice thing is, once again, right, we can put all of this on the right-hand side into our calculator, all right? So if you have a calculator with a view screen, all right, and this is what we recommend that you have, is, you know, you don't necessarily have to have a graphing calculator, but whatever calculator you purchase or use, get one where you can see what you type. Because notice now I can type all of this just like it looks on my calculator. So 8 squared plus 11 squared minus 2 times 8 times 11 times the cosine of 35.7. And so this is the advantage of having that view screen, because I can just type this just like it looks, parentheses included, exponents included, all of that good stuff, and I can hit enter. All right, so that tells me that a squared is equal to 42.07. And then notice, to solve for a, I just need to take the square root of both sides. Now, what's nice about my calculator, I can hit second square root, and I can hit second answer. Oh, I did not do that right, so let me try that again. So second square root, second answer. There we go. And that's going to type that answer right there in, and I'm going to get 6.49 for my side length. All right. And then once again, if you do have to type it in, try to use, 2 or 3 decimal places, and that'll make your answer as accurate as possible. All right. So there's an example of how we use side angle side to solve for the law of cosines. All right, so let's flip to page 114. All right, and let's look for one of the problems where we can solve for an angle. All right, so let me look at my problems here. All right, so let's actually jump to page 115. I was on the wrong page here. And let's look at problem 5. All right, and so notice here we want to solve for angle R, and we have side, side, side. So we have all 3 sides. Now, all I'm going to do is, once again, just sketch my triangle real quick here. It doesn't have to be like super precise. So QR is 31.9, RS is 25.2, and then QS is 37.6. And really, I need to see this so I know if I'm solving for angle R, I need to know the side opposite R, which is 37.6. All right, so that helps me when we think about our formula, right? So we have to have the angle and the side opposite the angle, all right, when we set up law of cosines. All right, so then if I'm solving for angle R, all right, the first side I need to know is 37.6. So I'm going to have 37.6 squared equals, all right, and then here are my other 2 sides. So 31.9 squared, I'm going to just go to the parentheses around that, plus 25.2 squared minus 2 times 31.9 times 25.2, and then cosine of R. And so once again, now we know we're going to solve for R. So eventually I'm going to have to take, all right, the cosine inverse of both sides to solve for R. Now, here's what I advise you do when you solve for this type of problem. So the first thing I'm going to do is simplify the left side here. So I'm going to do 37.6 squared and get that number. So that's 1413.76. Now, the next thing I'm going to do is, this is a sum, and I'm going to get this sum right here by doing 31.9 squared plus 25.2 squared and simplifying that. So 1652.65. And notice this is all one number in front of cosine of R. So I need to multiply these 3 numbers out, and that's multiplication times cosine of R. So it's going to be like 6x, something like that. So eventually we're going to have to divide by this coefficient here. So negative 2 times 31.9 times 25.2 gives me, so this is negative 38.3 cosine of R. Okay, now, and the point I want to make is you have really solved this equation before, because this is really like, and I'm just going to make this a very simple type of problem, this is really like 10 equals 15 minus 3R, like that, right? So notice how it's constant, 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 minus a product, minus a product. And so notice if I were solving this equation, all right, most of you will probably solve by subtracting 15 from both sides and get negative 5 equals negative 3R. And that's exactly what we want to do right here. We're going to subtract this number. So 1652.65 minus 1652.65, just like that. So let's see what we get. Minus 1652.65. All right, so I get negative 238.89 equals negative 38.3 cosine of R. And then notice, once again, once I'm doing this problem, I would divide both sides by negative 3. And that's what I need to do now. Now I need to divide by that constant in front of cosine of R. Because remember, this is just some number. All right, it's representative just like R would be. And so now I divide both sides by that number. So let's do that. Oops, 38.3. And I get 6.23 equals cosine of R. All right, and I think I made a mistake somewhere. So let me pause the video here. Let me look over my work, and I'll be right back. All right, and I did make a mistake. This number is off. So I'm going to go back and change this. This should be negative 2 times 31.9 times 25.2. Maybe my calculator would work. All right, so it's not letting me put that in here. So let's try that again. So negative 2 times 31.9 times 25.2. I think I left a digit off when I did that. So this should have been, all right, negative 1607.76, which means this should have been negative, all right, now I'll write it right here, negative 1607.76 cosine of r. And that's important because now instead of dividing by that negative 38, I would have divided by that negative 1607.76 on both sides. And I apologize for that. All right, and so cosine always has to be between negative 1 and 1. You'll learn a little bit more about that, all right, next year. So let me try this again. So negative 238.89 divided by negative 1607.76. All right, that's much better. So now, I'm just going to write this over here. We get 0.148 is equal to cosine of r. All right, so now, if we were doing this problem, all right, we would have gotten 1.67 equals r, and we would be finished. But remember, we are solving for r, and so the way we have to solve for r this time is we have to take the cosine inverse of both sides, right? So then on your calculator, I'm going to go over here in the margin here. You're going to do cosine inverse of 0.148, and that's going to give us our angle r. All right, so second cosine inverse and 0.148, and that tells us that that angle is 81.5 degrees for angle R. All right, that's a very bad looking R. So angle R, there we go. All right, so I apologize if that was a little sloppy there. All right, so, all right, there you go. So let me go ahead and just do number 6 with you. All right, we're solving for an angle there again, so that way you can see a clean problem. Hopefully I can do this clean and see that all the way through without any errors. So let's do AJM here. AJ is 20.4, JM is 16.4, and AM is 25.3. All right, and we want to find angle A. All right, so here's angle A, and so that means we need these two guys to start our problem. Right, so the angle and the side opposite. So now, that means it's going to be 16.4 squared equals, and then 20.4 squared plus 25.3 squared minus 2 times 20.4 times 25.3 times the cosine of A. All right, so once again, let's just kind of work through, all right, simplifying. Let's see if I can get both of these on screen here so you can see most of it. All right, so let's do the left side first. So 16.4 squared is 268.96. Once again, I'm going to do my sum of squares here. So 20.4 squared plus 25.3 squared equals 1,056.25. And let's see if I can get this part right this time and multiply these numbers. 2 times 20.4 times 25.3 gives me 1,032.24 cosine of A. All right, so much better that time. So once again, we're going to start by subtracting this value from both sides here and moving to isolating our cosine function on the right side there. All right, so 268.96 minus all of that good stuff there leaves us negative 787.26 equals to that. And this time I'm going to divide by that negative 1032.24 on both sides. And 1032.24. And this time I get 0.762 is equal to cosine of A. All right, and then so once again, now to solve for A, all right, I have to take the cosine inverse to get my value for angle A. So let's do that. And that tells me that angle A is 40.3 degrees. All right, so there was a clean example of law of sines and for solving for an angle, or excuse me, law of cosine, solving for an angle when we're in side, side, side. All right, so you guys wrap up that lesson, and I will see you next time.